好不能冇問題啦。
Hello, YouTube.
We have the intro. So, today we're going to be going over how to create your robot as an object in Android Studio. So, first of all, you need to know where you're going to write your code, right? So, conveniently enough, there's a bunch of random files that no one tells you how to use when you first import the FTC app, right?
Yeah, it's because you're bad.
Okay, so thanks, Isaac. All right, so OCV and OpenCV, ignore those. Those are third-party softwares I installed to allow us to run computer vision. We might get into that a little bit later. So, where do you want to write your code? Well, you want to open up the team code folder, right? Click that, and then now you have to dig through like 5 different files in order to get to what you actually want. You can see that currently our team code folder is full of a bunch of different stuff. Decent amount of it is example code, and yeah. So, how to create your robot as an object. So, the class we're using to create our robot as an object today is called teleop map. This is the hardware map that my team uses for teleop. Surprise, surprise. So you're going to want to start off with importing all of the hardware you need, right? So you can see it says com.qualcomm.robotcore.hardware.crservo, DC motor, etc., etc. All of that is stuff you need in order for your rev hubs to recognize your robot, right? And then, it also says the package at the top. Don't worry about that. Just leave it there. So if you've written objects before in Java, this is really not that complicated. But if you don't know how to write them, it isn't too hard to learn either. So you can see public class teleop. That's the name of the class. So you start off by declaring the variable names for all of your motors, right? I don't have any example for servos here, because my team has opted not to use servos because we have a bunch of spare motors, right? And we're fitting under 8, so we're all good. So you can see that we have each motor on our robot has a name, right? We have them called motor FR, motor FO, RR, RL, slide, actuator, and intake, right? And then we also have this variable. Ignore that. That actually we don't need that. I'll delete that. Okay, maybe that can get edited out too. Yeah. So you can see all of our DC motors are declared here as variables, right? It's just that they have the type DC motor instead of like int or string or anything like that. So next you need to local op mode members. Yeah, this is based off the example code. That's why like some of the styles of the comments are really weird in some spots, because I haven't actually written it. This was originally based off of the example code file, but So you can see hardware HW map equals no. That's just saying that, there's no hardware map right now. We're going to make it later, right? And then it also starts a timer so that later in other parts of the code, when you check how much time is left, it'll have started the timer. So the constructor, when I first wrote this, I went, wow, I have no idea what that does, so I'm not going to touch it. And actually, when you look at it, it does exactly what you'd expect. Nothing. So it's just so that when you call this class in another class, it, actually runs the class, basically. Right? It basically allows you to use this class in other classes. Constructor for our class, right? So for those of you who are new to programming objects, just don't worry about it. Just leave it there. You need to have these lines of code in order to be able to use this class and other classes. Just leave it, don't worry about it, right? So next, we need to initialize standard hardware interfaces, right? So you can see public void init, right? This is a method that starts up all of the hardware on the robot, right? And as you can see, there's a lot of stuff to initialize, right? So
Right.
Okay, every time he says right, just say it right.
Right.
Alright, we'll be quiet.
Okay, so okay, so